Good day, class. This is Ms. De La Torre, and welcome to the Introduction to Environmental Science. Earth is the only planet in our solar system that is known to carry life, and it has been known that the very first forms of life on Earth are thought to have been microorganisms that existed for billions of years in the ocean before plants and animals appeared. As of today, this blue marble we're seeing right now on the slide houses approximately 8.2 billion people on top of other living organisms. But the question here is, are we only living in this physical world? Where are we living exactly? By studying biology, chemistry, geography, and earth science, we get to know more about our natural world. These fields of natural and physical sciences allow us to know that our natural world is actually characterized by biological diversity among its living inhabitants and physical processes that aid in the survival of these living organisms. But politics, culture, norms, and traditions, which are product of our social relations, apparently affect the way we live on Earth. This human environment, where ideas and practices that are typically studied in the field of political science, economics, communications, arts, and other social sciences, have in one way or another influenced our way of living. So our society is regulated by laws and traditions based on the culture to which we belong. This only shows that we are living in both a natural and a social world. And sometimes integrating these two causes tension. Like what Barbara Ward says. For an increasing number of environmental issues, the difficulty is not to identify remedies. Remedies are now well understood. The problem is to make them socially, economically, and politically acceptable. So, what does this mean? Let's take global warming and climate change as an example. This has been an ongoing concern for human beings, and we are continuously making our best efforts in managing, if not fully solving, this environmental concern. But, like relating back to what Barbara Ward says, we already know our problem, and again, in this case, that is global warming and climate change. And we obviously know how to solve it. For example, we can try to minimize, if not fully stop, the use of plastic. Okay? But why is it that we cannot fully stop the use of plastic and other pollutants that we draw from different industries where we work into? That is because, for example, again, going back to the plastic manufacturing industry, if we try to stop and shut down all these particular manufacturing factories, okay, what will happen is that a lot of people will get displaced, especially those who are directly working within these industries. And this is going to cause a domino effect, which will most probably have a bigger economical impact in a specific country or area where these plastic ban, or technically, the shutdown of plastic industry will occur. And that is where this particular conflict occurs. Trying to stop the utilization of plastic is one of the things that can help us mitigate and manage global warming and climate change. But it's not economically acceptable because it's going to incur a great economic impact, especially among individuals whose job depends on this particular industry. Okay? Now, how are we going to work around this particular case? Does that mean that we should choose between natural world and the human environment? Even if we both know that we are living at the same time in these two worlds? The answer here lies in understanding and studying environmental science. That is because environmental science informs policy, because it provides information for decision making about resources and living systems that we occupy. By understanding and studying environmental science, we get to somehow meet at the center of these two worlds and try to minimize the tensions that may occur between the two. Now, how does that work? Obviously, studying environmental science also requires us to be quite familiar with some terms such as environmental engineering and the social movement called environmentalism. If we are to define environmental engineering, obviously professionals here are called environmental engineers, and they solve problems and design systems using their knowledge of environmental concepts and ecology, thereby allowing them to provide solutions to various environmental problems. Obviously, this is a more formal branch of science, whereas environmentalism, like what I said a while ago, is a social movement where citizen that doesn't only mean environmental engineers, okay, are involved in activism to further the protection of environmental landmarks and natural resources. Now, what is environment to be exact? If we are to define an environment, this actually refers to what? The living and non living surroundings that is relevant to an organism. It incorporates physical, chemical, and biological factors and processes that determine the growth and survival of organisms, populations, and even communities. Let's take, for example, your classroom. The classroom where you are staying and studying within our university can be considered as an environment. Because obviously, your entire classroom is made up of different non-living components such as ventilation, lighting, and the arrangement, okay, of chairs and tables within it. The glass boards, all of those, even if they are or these or rather are non-living, technically affects the way you live within that particular classroom. If the ventilation, lighting is good, then that will be favorable and provide you with a conducive environment for learning. On the other hand, if these components of your classroom are not in good condition, technically it's going to compromise the way you learn things. And that's not only isolated with, you know, classroom setup. Even your environment at home is another example of environment. Okay? It's technically made up of living and non-living things or components that one way or another directly and indirectly affects you. Now, let's talk about science. Since we've defined environment, science, as it is known to be the process of producing knowledge. It actually comes from the word scientia. And here, generally, science helped us find practical solutions for many problems. But how does that work? How does science help us identify practical solutions to solve our problems? Obviously, first off, science is empirical, meaning it depends in the utilization of our different senses. And by using our senses, we can get or make precise observation of the natural phenomena within our environment. Thus will allow us to further formulate reasonable theories to make sense of these observations. By doing this systematic approach of solving problems in the form of scientific method, we reduce our tendency to rely on emotional reactions and unexamined assumptions. Science searches for testable evidences. And if we're going to look at it, scientific method actually, let me just get here, is what? Is the method or the instrument that is used by science to seek about what is truth and what is not. Okay? Because obviously, observation is not enough. We have to have a system whenever we are trying to solve problems. Another thing to take note of when it comes to scientific method is that this tries to reach the high probabilities that an idea is correct within the framework of observations and tests from which it is derived. It is logical or systematic. Okay? And because of that, okay, activities here are designed to gather information and test ideas. But again, we can identify different ways on how to test ideas, okay, in a lot of ways. Now let's go back to environmental science. If we're going to merge now the concept of environment and science, again, that is where environmental science gets into. And again, always remember environmental science being the merge of these fields makes it what? Multidisciplinary or interdisciplinary. As you can see here in our slide, there's a lot of fields that we can relate environmental science into. For example, if the problem here in our illustration is depleted fishery, in the context of ecology, environmental science can ask questions like how does the reef support the fish? Because in ecology, we what? Study the interrelationship of the biotic and abiotic factors in the context of their environment. In chemistry, being related with environmental science, we can ask a question like what levels of oxygen, nutrients are best for the reef health? Because again, oxygen and other nutrients that may also involve biomolecules such as lipids, fats, proteins, and carbohydrates falls under the field of chemistry, which is also under environmental science. Another field that we can relate to environmental science is political science. And if that's the case, we can ask questions like how do we develop equitable fishing policies so as to avoid the problem or to solve the problem about depleted fishery? Again, environmental economics, population biology, anthropology, and religion, as well as other fields, can also be related with environmental science. And that makes it very important, okay, when it comes to what? Studying. Regardless of your program or your courses, it is vital that we study environmental science. With environmental science, it uses scientific approaches to understand the complex system in which we live. Okay? Now, let's try to check the different ways or reasoning, okay, that we can use whenever we try to imply scientific method. Now, I believe everyone might be quite familiar with this tool already. So, when we talk about inductive and deductive reasoning, these are two reasoning patterns that we can use, okay, as our approach whenever we try to use scientific method to solve problems. Again, if we talk about inductive reasoning, this is where we're drawing a conclusion based on several observations, and its pattern starts from a specific idea going to the broader or general idea. Observations of specific events here is used in the formulation of a general bigger statement, whereas deductive reasoning is the opposite of inductive reasoning. Deductive reasoning draws a specific conclusion from some larger assumptions. We start from the general or the broad knowledge to more specific statements to come up with a general conclusion. Usually, this type of reasoning is the one where predictions leads to an if-then statement. Okay? So again, whenever we talk about inductive and deductive reasoning, they are very important because again, simple observation is not enough. This pattern of reasoning allows us to have a more organized way of approaching scientific method. And again, inductive reasoning draws conclusion from specific to general, whereas deductive starts from general to specific. Now, regardless of your references, okay, the most common step that makes up the scientific method involves first identifying or stating your problem or the statement of the problem. Okay. Second will be the formulation of your hypothesis. And the third one will be to collect data that is based on your hypothesis. And the fourth one will be what? To test the hypothesis itself. Lastly, once you're done testing your hypothesis and you've gathered data and analyze it, that's the time you're able to formulate a conclusion or generalization. Always remember that whenever we talk about hypothesis, this is also known as what an educated guess. We're still guessing, but again, the idea that it is educated is because you are guessing based on your previous schema or knowledge about a topic. It is based on your observation and experience and preliminary information gathering. Hypothesis is your what? Is your what do you call this one? Working answer to your problem. Okay? It's your prediction. Okay? It's the one you're trying to prove, so it is going to guide you. It's very important that you know how to formulate hypothesis properly because without doing so, tendency is your research might have a different what result than the expected. Okay? Whenever we talk about hypothesis testing, on the other hand, that is the time when in a typical research we conduct our what methodologies and experimentation. Now, let's try to put this different steps in an example. Okay, let's say you are visiting a zoo where wildlife are expected to be seen, but as time passed by, you notice that whenever there are a lot of visitors in a specific area, wildlife visibility decreases. You may try to ask a question like what causes wildlife visibility to decrease in a specific segment or area of a zoo. So that is our problem. And again, the problem was drawn from your observation. Now you may try to what? Formulate a hypothesis based on your previous experiences. You notice that whenever there's a lot of visitors going in a specific area and staying for quite some time, wildlife visibility there decreases. So we may try to come up with an hypothesis that says because of the noise coming from the zoo visitors in a specific area of a zoo, wildlife visibility decreases. Now, to test that hypothesis, we need to further what? Collect data. You can try to visit the zoo at different times of the day. You may try to interview different personnels working in the zoo. You may try to also check and research about the behavior, okay, of different wildlife species present within the zoo and how they tend to get or they tend to react with what? Visitor noise. Now, after collecting those data, you may now start trying to what? Test your hypothesis. You can try to, for example, again, focus on a specific area where wildlife is expected to, you know, be visible. Okay, and try to observe it in different times of the day. Let's say, for example, during the morning when there's not a lot of visitors in that specific area, you may take note of how many species are visible at the same time. And you may also try to check it in the afternoon when there's a lot of visitors visiting that specific area and counter check what? The visibility of the wildlife species present there. And then let's say, for example, that after trying to observe it 7 days a week, okay, you're able to find a pattern and notice that whenever there's a lot of visitors or bulk of visitors gets into that area, these wildlife species tends to get stressed because of the noise, so they hide, affecting their visibility. Okay, You can then start to what? Formulate your conclusion. And in this particular example, we can say that based on your further observation, guided by the behavior of your selected wildlife species and the time and the bulk or number of visitors visiting that specific area, you can say that the higher the noise coming from the zoo visitors, the lesser the expected wildlife visibility because these animals are experiencing stress from it. That can what? Therefore answer your hypothesis or whether you accept or reject it. In this particular case, we accept it. Does it answer the problem? Yes. Now what's the next step? Obviously, we do not what? Stop when we already, get a conclusion or draw a conclusion from what? Our research. The next thing that we have to do is to share what we've come up with. You can try to consult the management of this zoo so that they can try to do something about it and mitigate what is being observed among its wildlife species. To take note and to take care of the welfare of the wildlife species, and at the same time to also educate the visitors regarding the impact of noise pollution among these animals. But is scientific method only applicable on such cases? No. As simple as the typical day-to-day concerns or problems can also be solved by what? Scientific method. For example, the problem is your phone charger is missing and you need to use it. Based on your observation and previous experiences, whenever your charger is missing, you always find it being used by your sister. So you can formulate again a hypothesis stating that if my phone charger is missing, most probably it is with my sister. Now, what's the next step that you need to do? You have to collect data, try to ask questions, try to think when is the last time that you can recall you've used it. You can also ask questions to the other members of your household and check with them. And let's say, for example, you already asked questions to all of your family members except your sister. Okay? This is the time you can test a hypothesis. You can try and go straight to her, ask her directly if the charger is with her. And if she said that she doesn't know where it is, then what does that mean? Obviously, you reject your hypothesis. It doesn't necessarily mean that whenever your charger is missing, it's always with her. Now you can go back to what? Your free views, um, or like the latest thing that you can recall about where and when or how did you use your charger. Okay, the last time you can recall it. And let's say, for example, that you also remembered you've tried to use it within your bedroom. Okay, you can try to check and look for it by sweeping under your bed, checking the bedside table and all. And then let's say, for example, you've seen it there or found the charger. So we can therefore conclude that what? Whenever your charger is missing, it's either it's being used by your sister or it could also be what? Could also be lost. Let's say, for example, you got, I mean, like it, and it was just left within your bedroom. Okay, so as simple as that. Okay, you can try to see how we solve problems um, following scientific method as what? The backbone. Now, there's this word here called reliability and validity. Like, how do they differ from each other? If we talk about reliability, okay, here, as it is being defined in the slide, the quality of measurement or the consistency or repeatability or the actual measuring instrument or procedure. Whereas validity refers or is related to what the success at measuring what is set out to be measured. Reliability is the feature of your what data and your test results that allows it to be repeated at the same time. And whenever it is being repeated, it provides consistent result or the same result. That means it is a reliable um, manner or approach in solving that particular problem. Okay, when you always get the same result again and again, whenever you repeat the procedure, okay, that means the procedure is reliable. On the other hand, whenever we talk about validity, that is when the result of your test is equivalent to what is expected of it. Okay? It gives us the correct, okay, the accurate answer to your problem. Okay? Now, always remember, you can be reliable or the result of your test can be reliable but not valid at the same time. Okay? Because reliability focuses on how your test can be done consistently and repeatedly, whereas validity is related most likely with what? With accuracy. Reliability is with precision, validity is with accuracy. So always remember that reliability and validity differences. If your answer is consistent, your procedure is consistent, then it's reliable. But if your procedure, despite of being consistent and despite of being able to be repeated over and over again, but always gets what? A wrong answer, then it is reliable but not valid. Okay? Validity is more of what is accurate. Reliability is more of what is precise, what is consistent. Let's talk about observation, inferences, and facts, and how do they differ from each other. Again, whenever we observe, we use our five senses, or we can also use instrument to measure those things that is beyond what we can sense. On the other hand, if we talk about inferences, this refers to what? Our generalization that is based from the observation. So again, our inferences relies on what we observe. Our observation technically relies on what? Our five senses. Fact is where almost everyone agrees with what is being observed about a particular thing or about inferences. If everyone or majority agrees with the inferences that is made from your observation, then we can build its credibility to be a factual information. For example, we observe a substance that is first white, crystalline in structure, and tastes sweet. We observed it obviously using our senses. Based from that one and our previous knowledge about things that is white, crystalline, and sweet, we can infer that most probably this is sugar. And when others try to check and come up with the same inference, then that's the time when it can be built up as something that is factual. Another thing that we can take note of is what? The concept of independent variable, independent variable. Independent variable in a specific test, okay, or problem refers to the variable or the thing that is being manipulated. Dependent, on the other hand, is the thing or the variable that changes whenever a change has been done in the independent variable. So, for example, in the case of our noise from the zoo visitors and the wildlife visibility, if we're going to check, okay, the independent variable here is what? The noise from the zoo visitors. Because whenever there's high amount of zoo visitors, that increases noise in a specific area of a zoo, wildlife visibility is affected. But whenever there's amount of zoo visitors, okay, decreasing noise, wildlife visibility increases. So in this case, the independent variable is the noise from the zoo visitors and the dependent one is our wildlife visibility. Data that we use, okay, to solve problems using scientific method can be categorized into two. We have quantitative data and qualitative data. Quantitative data from the term itself are those that can be expressed in numerical value. In our example, we can take, let's say, the noise pollution measurement, okay, or noise measurement in the unit decibel. Qualitative, on the other hand, refers to those data that is categorical or descriptive by nature. They cannot be expressed in numerical value or form. Okay? Now, another thing to take note of whenever we talk about scientific method is scientific law and scientific theory. How do they differ from each other? In this particular case, whenever we talk about scientific law, as more and more evidences comes in a consistent way that is also agreeing with a specific theory, okay, and at the same time, it is something that we can prove mathematically. That's the time that we produce scientific law. Scientific theory, on the other hand, is when experimental evidences continue to support hypotheses. Okay? We can say that scientific theory is where scientific law comes from. Okay? So the evolution is hypothesis, scientific theory, then scientific law. When the scientific theory, as consistent as it is, becomes something that can be proved using mathematical equations and expressions, then we come up with scientific law. But if it is something that is consistent, okay, consistently supporting a hypothesis, but we cannot prove through mathematical expressions or equations, then it still remains a scientific theory. Now, let's talk about environment and the tourism and hospitality industry. The relationship between the environment and the tourism and hospitality industry is quite complex. Why? Because or both industries are heavily reliant on a healthy environment, while also having the potential to negatively impact it. So, it depends. Hospitality management or hospitality and tourism industries depends on a healthy environment, but by doing so, by depending on it, obviously, it incur negative impact. So let's take for example some of the possible or the what positive impact of tourism and hospitality industries when it comes to our environment. First off, because of hospitality and tourism industry, we get to have financial support for conservation um, practices in campaigns. We also are able to provide environmental awareness through these two industries and advocate for sustainable practices. Infrastructure development is also being highlighted because of these two industries, and at the same time, they also act as agent for cultural preservation. But we also experience environmental degradation because of these two fields. They also encourage resource depletion, okay, and habitat loss and fragmentation when natural ecosystems are being converted into establishment that promotes hospitality and tourism. Okay, in a way, they also contribute in climate change because of the habitat loss and fragmentation and land conversion. Overcrowding and congestion is also being encouraged, okay, because tourism and hospitality industries um, heavily rely on what? The large number or bulk of tourists, okay, to visit a specific area, promoting overcrowding and congestion. And when there's a lot of people or individuals staying within an area, waste management issues also arise. Now, let's talk about the importance of environmental science for tourism professionals. As self-explanatory as it is, these are just some of the importance of what studying environmental science, especially among students like travel and tourism um, professionals in the future. First is they get to understand environmental impacts of tourism and hospitality industries. They get to know more about the specific ways on how to promote sustainable tourism practices and conserve natural resources. By learning those, they get to enhance the tourist experience and at the same time aid in ensuring the long-term viability of an environment where tourism and hospitality industries can thrive, okay, while environment is also in good condition. We can only do that when we achieve what? Sustainable development practices. But what is sustainable development? If we are to define it, okay, this refers to the what? The development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Sustainable is not only what? It doesn't only mean that you are replacing things so that others can use it, but in this particular definition, okay, you are utilizing something in a way that is very what you get to maximize how you use resources now in a way that you replace it as well and sustain it so that the future generation will also experience it the same way as much as possible. Now, sustainability or sustainable development follows this triple bottom line approach. Okay, sustainable development is not only focusing on what? It's not only focusing on one aspect. Okay, because as we know it and as we mention it again, we're living in both a natural and a human environment. Okay, and both environment has its own needs and its own wants, its own standards to where it is going to tried. So how are we going to get the Goldilocks? spot. Kumbaga, how are we going to meet at the center or halfway so that everyone will be happy? That is when we achieve sustainability. But when do we achieve sustainability? Triple bottom line is participated by three key factors, such as the planet, the people, and the profit. Okay? When people and planet meet, we only achieve something that is bearable. When people and profit meet, we achieve something that is equitable. When planet and profit meet, we achieve something that is viable. But again, those are not enough. Sustainability is at the center of those three. When planet, where natural resources, water and air quality, energy conservation, and land use is. People, well, social variables dealing with community, education, equity, social resources, health, well-being, and quality of life. And profit, where economic variables dealing with the bottom line, cash flow, okay, meet being bearable, viable, and equitable join forces. And that is when what sustainability is achieved. When a practice, okay, meets an environment, our environmental goal for our planet, our economic goal for our people, or for our profit, and our social goals for our people simultaneously, okay, what we are achieving a sustainable approach. Okay? Whenever we talk about sustainability, aside from the triple bottom line, IPAT equation is also another thing to take note of. This is designed in an attempt to define the different ways that a variety of factors can contribute to environmental degradation or impact of a particular setting. So, um, excuse me for those letters that are no longer visible, but let me just guide you through the legend. Obviously, I stands for the impact on the environment. Okay, so what we wanted to achieve here is what? A lesser value. The lesser the value of I here means the lower the impact or the environmental degradation. Okay, P here stands for what? The human population. A stands for the affluence of the population, and T stands for what? The technology available to the population. So let's try to check it one by one. Obviously, this equation um, is powered by multiplication, so it magnifies things. So that only means if we have large number for P or population, A for affluence, and T for technology, that's going to multiply the power of these factors, okay, leading to environmental degradation. So let's say, for example, we have large amount of human population residing or going in a specific tourist spot. Tendency is the impact or the environmental degradation in that specific area will get multiplied to what? The affluence of that population. When we talk about affluence, that's like the resources of those people. Obviously, if you have lots of money to spend on a lot of things, then therefore it is expected that you can consume way more than the normal or the usual, right? So if there's a lot of money within the system or within a population, the higher the what? Tendency for them to consume resources within the environment. Plus technology availability. Okay? If these population here, aside from being affluent, is also or has a direct access or easy access to the latest technology, tendency is they're going to make use of it to maximize its use. And that's also going to what? Multiply the impact them to environmental degradation. Okay, so that's the IUPAT equation. It magnifies or multiplies what? The human population, their affluence, and their access to technology available in relation to their potential environmental degradation impact. Okay, the higher the value of this, the higher the environmental degradation. Now, we also have this precautionary principle. From the term itself, precautionary, so we can say that it is like some sort of an environmental risk management approach. We, as human being, again, tries to solve problem in a way that we know how to do so. Okay, but again, sometimes a lot of factors needs to be considered and not all of those are being achieved. But again, at least we're doing our best, right? So precautionary principle is one attempt, okay, to help us help our environment. Here, when the health of humans and the environment is at stake, it may not be necessary to wait for scientific certainty to take protective action. It's like what? Following the approach of prevention is better than cure. You do not need to wait for you to get sick first before you take care of yourself and avoid doing things that may cause you to be sick. It's like that approach. Okay? You do not wait for the things or the problem to happen first. Okay? But instead, you are already doing things to counteract it, to avoid getting into the what? The problem itself. That's precautionary principle, but it's not always applicable. And that's, again, case to case basis because sometimes not being able to apply it properly can be quite counterproductive if if you get what I mean. Okay, but again, that's one environmental risk management principle, again precautionary principle, where we do not wait for a scientific certainty about a specific environmental problem to be present first before we try to be proactive, and um, do something that will help us avoid getting into that particular problem. Okay, now let's talk about how we value our environment. There's actually different ways on how we view and give value to our environment. Okay, and let me just run through some. Actually, this is where our lesson will be ending. Okay. First off is utilitarian justification. We also have ecological justification, aesthetic justification, recreational justification, inspirational justification, creative justification, moral justification, and cultural justification. Now, what does this mean? Let's talk, for example, first with utilitarian justification. This is where we view environment as something that benefits individuals economically or is directly necessary to human survival. Like we draw the raw materials from our environment that allows us to live. For example, food, raw materials for our shelter, right? So that's the utilitarian justification. Environment is important because that is where we get our primary needs. That's utilitarian justification or point of view. Ecological justification or point of view, on the other hand, believes that ecosystem is necessary or important. That's why we give them ecological value because they help us survive. Okay, survival of some species of interest to us, or that the system itself provides some benefit. It provides what? All the necessary things other species needed to survive. And if those species are also integral to our own survival, then we should value environment. So that's like ecological justification. It's either we have a direct benefit drawn from the environment, or they benefit the survival of species of interest that is beneficial or crucial to our own survival. We also have aesthetic and recreational justification. I actually just mixed the two here. With aesthetic and recreational justification, this have to do with our appreciation of the beauty of the nature and our desire to get out and enjoy it. Whether we like it or not everyone loves city view. Others actually appreciate our environment by doing hiking, by doing glamping or camping, and others that is directly related to our environment. We also cannot argue that just by looking at the green scenery also affects how our mood is being relaxed. Okay? And how the beauty of nature directly affects our mood. Another example is what? Inspirational and creative justification, where we give value to the environment because it serves as our inspiration. A lot of artists gets their idea from our environment, from the nature themselves. Okay? As what the slide says here, nature often aids to human creativity. Okay? It is embedded within us to take care of our environment. That goes for inspirational justification. With moral justification, it has something to do with our belief that various aspects of our environment have a right to exist and that it is our moral obligation to help them or at least allow them to persist. Okay? Like, if we have our rights, other parts of our environment and even our environment itself has a right to thrive. Okay? And we have a responsibility to take care of them. Lastly is cultural justification. This refers to the fact that different cultures have many of the same values, but also some different values with respect to environment. Different norms, culture, and tradition can be attributed with our environment, especially this is most commonly seen among indigenous people. And with that, we have to respect our environment because all of us has one way or another connection with our nature through culture. And that ends our lesson about the introduction to environmental science. I hope you learned something new today. And this is Miss La Torre. Thank you for listening.